Hi there, guys. This is Mr. Salceda with a quick video update for my B days. I won't be here on Friday, nor would I be here on the second half on today. Today is October 24th, and I just want to give you guys a quick recap on what you can expect on your test. I will give you the 2 days to finish the test, but other than that, as soon as I finish, there will be another assignment for you. So let's go ahead and get started. So let me give you a quick recap on the rational root. Okay, and just remember that they can also use the Q. Wait, I don't know if you get that. So instead of the word rational, let me use that. So the rational root theorem, let's say I give you this example, x to the third plus 3x squared minus 14x's plus 8, and let's pretend this is f of x. Okay, so the rational root theorem requires you guys to work with p, which is that all depends on whatever your constant is. So in this case, my p is going to be my 8, and the other value is going to be your q. So where's my q? My q is always going to be the one with the highest exponent. So in this case, the coefficient of x to the third power, that ends up being your q. So what do we call that? Just 1. Now, it's up to you how you want to do this part, but this next part is pretty simple. So what we're going to do now is we're going to get the factors of p and q. So plus and minus factors of p. In this case, we have an 8. So factors of 8 is 1 and 8, 2, 4, and that's it. So now we do the same thing for q. In this case, we have a 1, which is a pretty easy one because just the factors are 1 and 1. So when you use the rational root theorem, remember, we use plus and minus p over q. And when you do this is, and I forgot to put the plus and minus here. So just FYI, they're supposed to have plus and minus. So when you use the rational root theorem, you're going to divide all these terms, all the p terms by q. So in this case, since your q is only has the factors of 1, I'm just plus and minus 1 divided by 1, plus and minus 2 divided by 1, plus and minus 4 divided by 1, and plus and minus 8 divided by 1. And when you simplify these, just make sure that you don't repeat the results. So in this case, 1 over 1, well, that's just going to give you, plus and minus 1, plus and minus 2 over 1 gives you just plus and minus 2. Positive negative 4 over 1, it just gives you 4. And positive negative 8 over 1, that's just going to give you 8. So my conclusion here is going to read, there are 1, 2, 3, 4, so therefore 8 possible solutions or roots, right? In this case, you don't have to elaborate that much. You don't have to do it the extreme that I used to do it for you guys. I'll be very happy if you, at the very least, just give me this statement. Again, for students that plan to just use the graphing calculator, I will only give you half credit if you give me the actual solutions. I must see you guys using the rational root theorem. You don't use the rational root theorem, I will not be giving you guys any additional credit for the problem. So I'm only giving you half if you give me the solution. So just FYI. So let me open another page. Okay, so Not sure how you navigate through this, but let's see. I wonder how you navigate through this canvas. So let's do a new drawing. So now let's do another example. So let's say we get, f of x equals 2x to the third power minus 3x squared minus 11x plus 6. So let's say for some reason, well, we already know that a constant, that's going to be your p. So my constant is going to be positive minus 6. So therefore my factors of 6 is plus and minus 1, plus and minus 2, plus and minus 6, and plus and minus 3. Okay, so those are the only factors that the 6 has. So now let's talk about positive and negative q. In this case, the highest exponent is a 3, so therefore the coefficient of x to the third power, that's just going to be positive 2. Positive and negative 2 in this case. And since 2 is a prime number, it only has 1 in itself as a factor. So now, using the rational root theorem, I'm going to go ahead and divide the factors of 1, 2, 3, and 6 by 1 and 2, because all the p values have to be divided by all the q values. So 1 over 1 plus or minus 1 over 2 plus or minus 1, 2 over 1 plus or minus 2 over 2, positive negative 3 over 1, positive negative 3 halves, positive negative 6 over 1, and positive negative 6 over 2. Okay, and this is a particular example that I'm giving you because, again, you need to be aware that some of these repeat, in case you didn't know. So if I use, I wonder if it has a highlighter. Let's see. No highlighter, but okay. So if you notice here, for example, 1 over 1, because those two results end up being a 1. The other two that repeat, let me change the color here, is if you look at the 2 over 1, right, and you look around, that one's okay. But what about the 3 over 1 and the 6 over 2? We notice that those two give you a 3. So therefore, to save a little bit of time, I'm not going to rewrite those results. So the 1 over 1 and the 2 over 2, it's the same value. So therefore, my rational root theorem suggests I'm going to get positive negative 1, positive negative 1 over 2, positive negative 2, positive negative. Since the 2 over 2 gives you 1, I'm not going to write that one down. Positive negative 3, positive negative 3 halves, positive negative 6, which in this case, since the last one. So my conclusion for this one, there are 1, 2, 3, 4, 5, 6. So times 2, there are possible roots. And again, this is not for full credit. You don't have to do any more work. As far as the test is concerned, I don't think you're going to have to do so much work on this part. But just know that if I don't see you guys using the P over Q and listen to factors, and you just give me the solutions, for example, I'm not going to give you full credit for the problem. I need to see the rational root theorem being used. Okay? So I wonder how you shift pages in this. I'll need to figure out later. All right. So now let me talk about the last thing I talk about. So let's say I give you this example. 2x squared plus x plus 2, right? I'm just taking one out of my head. And let's say we use the quadratic formula. Right? Assuming that I wrote it right. There you go. That looks better. For some reason, can I see my cursor? Anyway, so we already know that this depends a lot on what you have. Remember, it has to be in ax squared plus bx plus c mode, where it has to equal to 0. So we know our baby blue brother is the number in front. So therefore, this one for b, it's going to be a 1. For candy apple red, we're going to get a 2. Oops, too much. And then for my last one, the constant, I'm going to plug it into. All right. So what's going to happen? I'm going to open another parentheses. So I'm going to do this one a little quick. So x of 1 and 2, that's equal to, open parentheses. Oops, but I forgot the negative. Open parentheses. That's going to be a 1. Plus and minus. 1 squared minus 4, 2, 2. Negative times the 1, that's negative. Minus 1 times 1, 1. Negative 4 times 2 times 2. Well, negative 4 times 2, that's negative 8 times 2, that's negative 16. So two times 2, that's 4. Right? And then in this case, we're going to have an irrational imaginary solution, which, by the way, don't worry about the imaginary part for this test. I won't test you on that yet. But just know that the rational, the irrational part, I'm still going to test you on that. So this is going to be square root of negative 15 divided by 4. And if you want, you can already split up the fractions. Now, we already learned that if you have the square root of a negative number, it's non-existent. So if you want to write it down like this, that's fine. But what you're supposed to do is remove the negative, and you're supposed to slap an imaginary I. That letter just tells the reader that the result you have there is a result from a square root of a negative. So then what's going to happen here is you're pretty much done. So if you want to keep it like that, that's fine. This is all you have to show me. Do any further. Now, if you're going to use decimals, you can use decimals. That's fine. Let me just show you what decimals is. Okay, so let me go ahead and project again. Decimals to approximate your answer, you can do that. So we already know that if you do 1 over 4 plus the square root of 15 divided by 4, because you have to press the right key before you take the square root. Well, not before you take the square root, but after you take the square root of the number, press the right key to make sure you're able to divide like this. And since it has I, right, remember that you have to switch it to complex mode. If you don't switch it to complex mode, you won't be able to get the answer right away, right? And there it is, right? Now, if you do square root of 15, So square root of 15. Press the right key, divide by 4. This is what it gives you, right? And again, I need to warn you that this is an approximate form. But if you don't want to use this as your answer, you're more than welcome just to leave it like that. And you're more than welcome to even just write it like this. And I'll give you the full credit, right? Let me just do one more before I let you guys go. So let me do this one. 3x squared minus 2x plus 1. So again, x of 1 and 2, open parentheses with a negative in front of it. I'm going to use plus and minus, negative 2 squared plus and minus. Oops, that was not correct. Minus 4, 3, 1. And just make sure you take the square root. And 2 times negative 2. So the negative times the negative, that's positive 4. Negative 2 times negative 2, that's positive 4. Negative 4, negative 12 times 1, that's negative 12. And in this case, I am getting a negative number here. So 4 plus and minus 4 minus 12, that's going to give me negative 8, which is going to be another imaginary. You know what the heck? I'll give you some imaginary numbers. So just make sure you switch to the complex mode, okay? And this will give you 4 divided by negative 4 plus and minus radical 8 I divided by negative 4, which gives you x of 1 and 2 is equal to negative 1 plus and minus radical 8 divided by negative 4. Okay, and again, that's all you have to do. You don't have to do much more after that. Okay, well, good luck guys in that test, and I'll see you around.